Okay, next let's look at a series of properties. We have some properties of identity and some inverse properties of both addition and multiplication. So let's take a quick look at those. So the identity property of addition means that when you add 0 to any number, this does not change the value of the number. So a number plus 0 just gives you that original number, and it doesn't matter which order. Okay, so that simply is the identity property of addition. The identity property of multiplication says that multiplying 1 by any number does not change the value of the number. And I think you may have heard me mention that a few times here in the past. So 1 times a number doesn't change the value of that original number. And it doesn't matter the order of the multiplication because of the commutative property. Okay, the inverse property of addition. So what this says is that for any real number n, negative n is the additive inverse of n, because when you add a number plus its additive inverse, the sum will be equal to 0. So basically what that means is a number and its opposite added together will give you 0. So for example, if you had 8 and you add a negative 8 to that, that's going to add up to 0. So a number and its inverse. Or if you started with negative 52 and you added a positive 52 to that, that's going to be equal to 0 because these are inverses of each other. Then we have the inverse property of multiplication, and this says for any real number n, where n is not 0, 1 over n is the multiplicative inverse of n, because n times its multiplicative inverse will always give you 1. Multiplicative inverse is something that we're going to talk about here in later chapters, so this one is also important. So let's say we have the number 5. The multiplicative inverse of 5 is 1/5. So what you do to find the multiplicative inverse is you just take a number. If it's a integer like this, you can put it over 1, and then you just flip numerator and denominator, and then that's where the 1/5 comes from. Let's say we had 2/3. Then the multiplicative inverse of 2/3 is 3/2. So I just flipped numerator and denominator there. Okay, so a number and its reciprocal multiplied together equal 1. So let's look at an example. So this first example, simplify, recognizing the use of the inverse property. So all three of these terms are like terms, but what you should notice is that this one is a negative 84n, and this is a positive 84n. So these two added together, because they're additive inverses, using the inverse property of addition, that'll come out to 0. And so we're left with just negative 73n for an answer. So try this next one here on your own. It's going to be very similar to this one. And if you have any questions about it, let me know. Now, this next example, let's look at the inverse property. And so this is 3 fractions being multiplied together. And what I'm looking for is to recognize that 7/15 and 15/7 are reciprocals of each other. So what we want to do is, just for the sake of clarity, we're going to put those together because multiplication is also commutative. The order doesn't matter. Right? And a number times its reciprocal always gives you 1. And 1 times any number just gives you that number. So that's that one. The answer on the next one should come out to 10 over 98. So that's not reduced, is it? Actually, I just caught that. So let's see, 1098, but we need to reduce that even further. So 10, we can write it as 2 times 5. That's its prime factorization. And 98, we can write it as 2 times 49, 18. Yes. Yeah, that's right. So we can cancel the 2's. Okay, so the answer for this one should be 5 over 49 as a simplified fraction. Okay, give that a try.